Welcome back, my friends. If you've been following along, you already know that Python is a powerful tool for enhancing your network skills. In our previous videos, we have explored how Python can automate network tasks and laid a solid foundation in Python tailored specifically for network engineers. Now, it's time to elevate your expertise. In this video, we'll delve deeper into Python's fundamental concepts, focusing on variables, data types, and operators, and how they play a crucial role in your networking toolkit. Whether you're configuring routers, managing switches, or monitoring network traffic, Python will be your reliable ally. So, if you're ready to tap into Python's full potential in the networking world, you are in the right place. Let's get started. Well, the first topic I want to introduce you to is data types. To better understand data types, think of them like various devices in a data center. For instance, switches handle switching tasks, routers take care of routing, firewalls manage firewalling and filtering, and so on. Each has a distinct role and function. By knowing the role of each device type, you can use them to manage and control network communications and traffic, right? In the Python world, data types are just like these network devices. They serve different roles, and you use them to manage data in your program or scripts. Before anything else, let's take a look at the data types available in Python. In Python, we generally deal with two categories of data types: basic data types and compound data types. The first category includes these data types: integer, floats, string, booleans. And the second category, called compound data types, encompasses these data types: list, dictionaries, tuples, sets. All right. Let's get acquainted with each of these data types with a simple and understandable example. First off, let's talk about integers. Integers are whole numbers without decimals. They are used to represent values like counts or indices. In the world of networking, you might come across something called port numbers. As you know, port numbers are used to identify specific services or processes on a computer within a network, and they are shown as integers. For example, port ID is commonly used for HTTP or web traffic. Port 22 utilized for SSH connections. Port 443 is assigned to HTTPS traffics. So you can think of port numbers as integers that help direct data to the correct service or application on a network computer. These integers play a crucial role in network communication and are an essential part of networking protocols. Floats. Floats, short for floating point numbers, are used to represent a real number with a decimal point. For example, think of measuring network latency or ping times in milliseconds. Ping times can vary and are often represented as floating point numbers to capture the precision of the measurement. For instance, when you're checking latency to a nearby server, you might get a ping time of 5.2 milliseconds. For a more distant server, the ping time could be 48.9 milliseconds. Who knows? In some cases, especially on congested networks, you might see even higher value like, let's say, 135.7 milliseconds. These floating points values in milliseconds are used to assess network performance and identify potential issues that network engineers like you need to address. Strings. In the world of networking, device host names are usually expressed as strings. These strings serve as a unique label for devices on a network. For example, a router might go by the host name router1, or you might find a switch named switch A, or even server could be labeled with names like web server-product or prod. These string-based host names are crucial for IT professionals to efficiently manage and set up devices. They simplify the process of recognizing and addressing specific network equipment within a broader network framework. Booleans. Booleans are like binary switches with only two possible values, true or false. They find frequent use in conditional statements and comparisons. For instance, in the realm of networking, Boolean serves as a handy way to describe the condition of network links. For example, when a link is up or active and data can flow through it, we represent it as true. This signifies that the link is operational. Conversely, when a link is down or inactive, meaning it's not functioning, we use false. This might occur due to hardware issues or intentional configuration changes. Network monitoring tools and scripts frequently employ Booleans to assess the status of different network components. This helps network administrators swiftly identify and address issues within the network infrastructure. Lists. Lists are essentially like digital containers where you can keep stuff in order. They are versatile and can hold different types of things, even other lists. To declare a list, you use square brackets. Here's a practical networking-related example, as you can see here. In the IT world, especially in networking, they come in handy for keeping tabs on devices linked to a network section. In this code snippet, network devices, here this variable, forms a list that holds the name of devices tied to a specific network chunk. This list is like a checklist that helps you easily find and deal with these devices in your network script or monitoring apps. Lists are super useful for tasks like running devices for configuration management, making changes to several devices together, or creating reports based on the devices connected to a network portion. Well, my friends, it's time for dictionaries. Dictionaries are like organized info cards. Each card has a unique label and some details. You set up dictionaries using curly braces with label and details. In the realm of networking, dictionaries are handy tools for storing and handling detailed data about network devices. This data might include things like their IP addresses, the brand they come from, and whether they are active or not. In this code, network devices variable takes a form of a dictionary. In this dictionary, each network device like router 1 or switch 1 acts as a label, and the associated data comes in another dictionary that holds info about that device. This setup makes it simple to access and work with device info. Dictionaries are super handy in network automation, whether it's storing device settings, tracking device changes, or managing an inventory of network devices, complete with key info like IP addresses, manufacturer names, and operational statuses. Tuples. Think of tuples like sealed envelopes. Once you put something inside, it stays that way. You can't change what's in there. Tuples are created using parentheses. In networking, tuples come in handy when you want to represent details about network interfaces. Each tuple can hold information about a network interface, like its name, IP address, and status. In this code, network interface variable takes the form of a tuple and it carries data about a network interface. This includes the interface name, IP address, and its current status. Tuples are super useful when you need to keep related data together and make sure it doesn't change while you work with it. In networking scripts, my friends, tuples are handy for tasks that involve the structured data, like handling interface settings, or when you want to ensure that your data remains constant and unchanged during your operations. Sets. Imagine sets like boxes of unique items. no duplicates allowed. Sets are made with curly braces and they automatically remove any duplicates. In networking, it's common to want a list of unique IP addresses for various tasks, like keeping track of active devices on a network. Sets are your go-to for this because they guarantee uniqueness. In this code, the IP addresses set automatically removes duplicates, leaving you with only the unique IP addresses. Sets are a real asset in networking when you need to handle distinct elements, such as IP addresses, and you want to be sure there are no repeats. Alright, great. Up to this point, you've had a little introduction to data types and their uses, especially with the examples I have given you. You probably understand how each of them can be helpful in the world of networking. But there's more to it. Throughout this course, we'll explore how to use these data types more effectively and precisely in the context of networking. Each of these data types, my friends, come with the methods that make them more versatile and efficient in various situations. In simpler terms, these methods are like tools that allow us to make use of the specific features of these data types according to our needs. You might be wondering what exactly is a method. Well, when the time comes, I'll explain methods in detail. For now, think of a method as a tool that performs specific tasks for us. For instance, if we need to make changes like adding or removing an item in a list during our program or a script, we require a tool that can easily handle that for us. And in this context, that tool is nothing but a method. So, each of these data types provides us with methods that enable us to perform specific tasks on each data type. Now, let's put data types into practice. What I mean is, let's see how we can write and define them and get more familiar with them. For this, I've prepared a Python file named datatypes, as you can see here, in VS Code. If you're not familiar with VS Code or coding environments in Python in general, don't worry. I've previously discussed the different environments you can use for writing Python codes and how to use them in a video, the link to which I have provided above. I explain the features of these environments there, so please go and watch that video. I should also mention that for your convenience and to help you better understand, from this point forward, I'll be writing more code in the IDE. So let's move on to VS Code. Well, as you can see, to efficiently use our time, I've prepared these codes in advance, but I've commented out all of them. As we proceed with each data type, I will uncomment the code related to it and execute it, so that we can separately view and analyze the results and outputs for each one. As I mentioned, an integer is a number without decimals. Well, here I have created a variable called port number and assigned the number 22 to it. Let me take it out of comment mode. All I need to do is to remove this hash symbol, or I can use simply Ctrl+// to do this. Now it's usable. Now, it is important to check the data type of this variable. In programming, especially when dealing with different data sources or user inputs, it's crucial to ensure that the data you're working with is of the correct type. For example, if you intend to use this port number in a script to connect to network device via SSH, it must be an integer. If it's not, it could lead to error or an unexpected behavior in your script. So, how do we check the data type of a variable in Python? Well, it's straightforward. We can ask Python what the data type of this variable is by using a built-in function called type, which shows us the data type of a value or an object. Now, If I run this code, you'll see that the output shows me that the value assigned to the port number variable is indeed of data type integer. And one more thing. As I mentioned earlier, each of these data types has various methods for performing different tasks on that data. I don't intend to delve into their details in this video, my friends. But let me show you how you can inspect the methods of a data type. For this, I use another Python built-in function called dir. This function displays a list of attributes and methods associated with each data type in the output. Take a look. Well, as you can see, in the first line, it shows me that the variable port number here contains an integer. This is essentially the output of the code. Here you can see print type port number. Then it lists methods and attribute of an integer, which is the output of print dir int. This is fantastic, because now I know what tools I have at my disposal to efficiently work with this data type and use them wherever needed. Alright, let's do the same thing quickly for all data types and see the results. Let me quickly mention one thing before we move on to the next topic. While it's helpful to use the type and dir functions to understand data types and explore their method, you typically won't need to use them every time you work with a variable. They are excellent tools for learning and exploration, but as you become more familiar with data types, you'll naturally understand their characteristics and how to work with them effectively in your code, especially in the networking world. Alright, my friends, as you have seen so far, I used variable to define each of the data types. And you have noticed that we call these variables in the type and dir functions to examine the desired results. By now, we know that variables are like containers that can hold something. Indeed, they are containers that store various objects, including data types. In fact, variables are symbolic names we use to store data in program. Their existence is essential for working with data because they allow us to manipulate data and refer to them by name throughout our code. To better understand, let me give you an example. In the networking world, you're familiar with the access lists. To define an access list, we use a name or a number, then specify whether access to a resources or another network should be permitted or denied. Finally, wherever necessary, we call it, like under an interface, in a NAT configuration, in a roadmap, in a QoS configuration, and many other places. Why? Well, a variable in Python has a striking resemblance to the concept of an access list in networking. But here are some key points about variables that you absolutely need to know. Assignment. Variables are created when you assign a value to them. As you have seen, you can assign various data types to variables, including numbers, string, lists, dictionaries, and more. Dynamic typing. Python is a dynamically typed language, meaning you don't need to explicitly specify the data type of a variable when defining it. Python determines the data type based on the assigned value. Variable names. Variable names, my friends, are case sensitive and can consist of letters, numbers, and underscores. However, variable names must start with a letter or an underscore. You can't use numbers or other symbols at the beginning of a variable name. Okay? Only letters and underscores are allowed. Reassignment. You can change the value of a variable by assigning a new value to it. Constants. If you have constants in your code, I mean values that do not change throughout the program, conventionally, they should be written in uppercase letters with underscores separating words. Scope. Variables have a scope, which determines where in your code you can access them. In other words, variables can be local or limited to a specific function or block, or global. It means accessible throughout the entire program. And the last one, data storage. Variables store data in memory. It means allowing you to retrieve and manipulate that data at a different point in your program. Well, my friend, Python variables are a fundamental concept in programming, and they play a crucial role in managing and processing data within your code. They are used extensively in various programming tasks, from simple calculation to complex data structures and algorithms. Okay, these are general rules about variables. As we delve further into this topic, you'll become more familiar with how to properly write variables, especially in the Pythonic way. Alright, my friends, let's move on to the last topic in this video, which is exploring and getting to know operators in Python. In Python, operators are special symbols or keywords used to perform actions and variable and values. Operators enable you to work with data, do calculations, make comparisons, and more. Python supports various types of operators, and here's a quick overview. Arithmetic operators. These operators perform math operations like addition, subtraction, multiplication, division, finding the remainder, and of course, exponentiation. Comparison operators. These operators are used to compare values and return Boolean results. That means true or false. Logical operators. These operators perform logical operations and are often used to combine or modify Boolean values. Assignment operators. These operators are used to assign values to variables. Bitwise operators. These operators perform operations on binary representations of numbers. Membership operators. These operators are used to test if a value is a member of a sequence, for example, a string, a list, or a tuple. Identity operators. These operators are used to compare the memory location or identity of two objects. Okay, well, these are some of the commonly used operators in Python. Understanding how to use these operators is fundamental to writing Python code for performing a wide range of operations, from basic arithmetic to complex data manipulation and decision making. Alright, now let's take a quick look at some examples of operators. As we delve deeper into this topic, you'll become more acquainted with how to use and apply operators, especially in the context of automation and programmability. In this video, my intention is simply to provide you with a basic introduction to them. In this video, we delved into basic Python concepts such as data type and their classifications, variable and their usage, and naming conventions. We also briefly explored operators and their applications. Through the example we discussed, we aim to provide practical and relevant insights for you as networking professionals and engineers. If you pay close attention, you'll realize that the world of networking and programming are not only interconnected, but also share similarities with the rules and norms of our social lives. By understanding these subtle commonalities and differences between these concepts, learning becomes faster, easier, deeper, and more applicable. I strive to make your learning experience easier and quicker by applying this concept in the networking domain. Learning Python using this method is beneficial for both network specialists and programmers. In today's rapidly evolving world of technology, traditional boundaries in IT are changing rapidly. We must be able to ride the wave of these changes, recognize opportunities, and reduce threats. So, whether you're a network specialist looking to step into the world of network automation and programmability, a programmer seeking to expand your knowledge into the networking field and write better applications, or a DevOps expert aiming to bridge the gap between dev and ops, stay with us on this channel. Thanks for being here today as we embark on this exciting journey into the realm of network automation and programmability. If you found this video helpful, a quick like and subscribing to my channel would mean a lot. By turning on notifications, you'll never miss any of our latest insights and tutorials, helping you stay ahead in mastering network automation and programmability. And again, I thank you for viewing.